Hey folks, welcome to another session of Odyssey Cloud. Today we have co-founder and CEO of CloudPilot AI, Jinkang. We are really glad to have you with us for this new session where you walk us through why we should look at CloudPilot and how you can save all the money within your Kubernetes setups as far as using CloudPilot AI is concerned.
Hi, Amit. Hi, everyone. It's really great to meet you. And I'm so glad that I can have this opportunity to introducing Copilot AI to you. And let's talk about the Kubernetes auto scaling.
Yeah. So I think one of the first questions people are going to have, like, hey, we already use auto scaling. We might be using Carpenter. We potentially are using tools like Goldilocks for looking at cost reduction or cost optimization. So Goldilocks would help us in identifying to right size our resources, and Carpenter would help in ensuring that you can scale your resources scale your servers as per the requirements of your workloads. um, your During all of this process they would have this question like, so how would we use CloudPilot AI, and how is it better than using Carpenter and Goldilocks?
That's a good question. In a word, I think cluster auto scaler is not as efficient as we want because they are not going to select the most perfect candidate instance from over 800 EC2 instance for every workload, and also they cannot manage spot instance, safely. For Carpenter, I think Carpenter is great, and previously I worked for AWS and I love Carpenter, but Carpenter is not as stable and reliable as you think. We have a lot of customers who are using Carpenter, but they met off a lot of issues in terms of stability, scheduling, reliability. Actually, I prepared the slides and I can explain more about.
Absolutely.
Okay, so let me share my screen. 1 second.
Yeah. And probably you could tell us a bit more of how did CloudPilot come about? How did you think about, starting CloudPilot, and what was your inspiration to do that too?
Okay, cool. Yeah, I founded CloudPilot AI 1 year ago in 2024. That is because of when I worked for AWS, I found a lot of customers who have a huge cloud waste, like 30% CPU utilization, which means that they over provision like 8x cloud resources than they want, and they got millions of dollars, bills monthly. So I see a lot of customers struggling about that. So I think is there any the very good solution to solve this problem? Yes, there are a lot of products in the market who wanted to optimize the cost or resources, but from my side that from my perspective, I think hardly or really few of them can do fully autonomous optimization. When I say fully autonomous, I mean you don't need to bother SREs to implement and deploy your strategy. You need to do it fully autonomous, was like autopilot. So
Mhm.
um, I started this company and built this product. um, so we want to do a smaller auto scaling like a SRE agent. This product is built for SREs, which we can help SREs to eliminate the cloud waste and boost application performance. The most importantly, reduce the risk by manual operations or autonomously. So this is a product, but today I want to talk about three topics. The first is why traditional auto scaling fails in Kubernetes. The second is what we build is a more performant, intelligent, and a simpler Carpenter. What is the difference with open source Carpenter? And the second is
Mhm.
a live demo. it's a live demo, and I will guide you to our product and say how can we reduce like 60% AWS cost in just 5 minutes, 2 clicks. Is that sounds
That
great?
is, that sounds fantastic. I think, especially in today's day and age, everybody's looking to see how we can reduce our infrastructure costs, why are our bills so high, and where we can fine tune. So this is definitely something which is very useful and very insightful for a lot of people out there. Let's go ahead.
Thank you, appreciate. Okay, the first question is what is the problem of class autoscaler? I think class autoscaler lack of efficiency. For example, in 2024, according to a report that over 80% of resources are underutilized in the Kubernetes. Its average CPU utilization is just 10%, and the memory utilization is like 23%. That's a huge waste. Um, if you're using class autoscaler, aka CA, we will find that you need to create like multiple node pools. You have M5 2x, you have C5 4x large. That's it. But generally we only have 2 or 3 SREs in a company. We don't have too much effort to manage like 10 node groups. If you multiple like 3 AZs, it will be like 30. That costs a lot of effort. The second is how do you choose the best one? When I say the best one, I mean the lowest price with the best performance for your workload. For example, if you have a microservices workload, it only needs like one course, 2 gigabits. But maybe people put this workload into a instance called like M52X large. It's 4 cores or 4 gigabits. That was a waste. Like we only have like
Hmm.
less than 30% CPU utilization. And I can tell you there are some rules inside this over 800 EC2 instance. Like if you know an instance called M5A, you know that it was powered by AMD. It has, I can tell you that the same performance with instance called M5, but its price is like 50% cheaper. In AWS EC2 world, any instance powered by AMD is cheaper than those powered by Intel at the same size. That
Hmm.
is one of the hundreds of the rules. I think most customers don't know the rules. AWS knows the rules, but I think they don't have a product to tell you. So what we are building is we have an agent, installed in your clusters, and we will analyze your cloud resources, no matter the utilization or the size or the spot or on-demand instance. Then we feed this data with our AI engine backend, and we got exclusive optimization plan for your cluster. This is the first one, and also the class autoscaler cannot do continuously bin packing. They cannot even do bin pack, right? Bin pack
Yeah.
is a very effective solution to compact the nodes to reduce the waste. The third is yes, CA cannot manage the spot instance safely. Spot instance is very cheap, like 10 to 20% price of the on-demand instance, but they would be interrupted or reclaimed by cloud vendors at any time. So from my perspective, from my experience, I can say only like 5% of customers who are using spot instance in the production system. In their production system, that's a very low adoption. The main concern is about the interruption. But
Hmm.
uh, I'll tell you that we have built a database called Spot Insight. It has a real-time historical data of price and interruption rate, in a region of over 800 spot instance. I will show you later. So we know every, spot instance interruption rate at any time in the day. That is the solution that we want to manage spot instance for our customers automatically, because we know at this time which one is the most, lowest price with lowest interruption rate. The second is, if a provider want to reclaim a spot instance, for AWS they will give you a 2 minutes notification. For Google Cloud, I think the notification is like 30 seconds. That was too short. That was too short for, for nodes to be recreated, for workload to be migrated. But because we know the time of interruption time of a spot instance, so we can extend this 2 minute notification to 45 minutes. To 45
Yeah.
minutes. 45 minutes is enough for node to be provisioned, your workload to be migrated. Okay, the last point is I think CA is too slow for scaling. We have a benchmark that CloudPilot AI can scale, provision the first pod within 50 seconds, you know, and we can scale into 1,000 pods within just 30 seconds, which is
Wow.
which is 5x faster than the class autoscaler. So I think this is the drawback of auto class autoscaler. Um, Okay, next topic is, what about the Carbona? As I said, I love Carbona, but I think Carbona is not enterprise grade. It was not enterprise ready. Um, if you wanna, you know, integrate Carbona into your production system, you have a lot of issues to solve. I'll give you like four aspects. The first is Carbona. They don't have multi-cloud integrations, right? They only support AWS.
Yeah.
Um, and I think Azure has an integration, but it was not major. It has a lot of drawbacks. For example, I think they don't have spot feature, and they don't have automatically node selection feature. So that is that is the first problem. The second is, I want to bring you to a use case of a single replica workload. If you have a single replica workload, Carpenter will evict the existing pod. I mean, delete the pod, then your pod got pending, which means that your service maybe have interrupted. Then, when the new node got provisioned, okay, this port get be scheduled to the new node, which means that your service maybe get done. But how do we, handle this single replica use case? CloudPilot AI, we will provision a new node at first. That when the new node get ready, we start migration your workload, from the old node to the new node. We want deleting the old nodes at first. So this
Yeah.
is a very useful feature for single replica use case. Trust me. Okay.
Yeah. Not
The
just that, I think you mentioned earlier that the scaling that happens on Cloud Pilot AI is up to 1,000, it's like 30 times, 30% faster. I think that is going to be a big win for a lot of people, because even when I'm working with my clients, when people are using their API, if they have, so one of my clients is a media company, and they might have a show that becomes famous, and only during that time they have this crazy traffic. So during something like that, Cloud Pilot would be very useful, because it's helping to simplify the entire scaling part of it. So there is a real world use case out there, so that's great to hear.
Yes, yes. Yeah, you reminds me another use case, which is for e-commerce clients. Like the Black Friday, or some promotion seasons. They got sudden traffic, but if you're using cloud, CA, it will too slow, or your
Hmm.
application will be um, interrupted. Great point. Great point. The second problem Carbon is they only provision spot, but they don't care about the spot interruptions. They give you 2 minutes notification, and you will handle this by yourself, by your own? That's a really tough question to handle. We do a lot of work on the spot automation. We can run Spotlight on demand. I can show you another screen. Wait a minute.
Hmm. Yeah, I do think it's very handy about the spot instances because there is no point of going and getting permanent instances if spots can make do very well and you can get the same level of CPU and server size, etc. Then that saves you a ton of money there, which again makes for a very good use case of CloudPilot and why it's very handy and useful to look into CloudPilot being your SRE agent, right?
Yes, yes. This is a Spot Insight database that we built. Um, Let me show you the yeah the dashboard. You can see you can choose one of the instance among the 800 instance inside a region in AWS. For example, T3 Medium, and you can see its architecture or any instance family. The most importantly, you can see the map, and we have a lot of dots, green dots, red dots. This represents the interruption rate. For example, this T3 median in US East to Ohio has extremely low interruption rate. When I say extremely low, we mean that it will be interrupted once a month. So which means it's really safe to use. But in St. Paul, yeah, I think St. Paul, South America, it has a very high interruption rate.
Yeah.
I promise you, when you provision T3 median in some power, you will be reclaimed like 15 minutes later. So that's
Wow.
what it's safe to use. Any questions, Amy?
No, I think one question which people would have is, do you have this only for AWS or do you have it for other cloud providers too?
Yeah, currently only AWS, but we will support a Google Cloud. I think by the end of next month, by the end of October, and we will support Azure by the end of this year.
That's exciting.
Hmm. Okay, this is an interruption map, and also you can see the price. Its price is really low compared to the on-demand instance. And another
Hmm.
tricky point is even the same instance, T3 media, in the same region, US East 2, its price varies in different AZs. You know, back to 1 month, you can see the price, I think, varies like 30% difference between different AZs. So the first question is, if you want to use in spot instance in Carbon, that's great. How do you choose from the over 800 spot instance, the lowest price with lowest interruption rate? You can, because you don't have this data. How do we collect this data? First, um, we have the base layer data from AWS, but it was not accurate. We will fine tune this data with our real data from our over 100 customers around the world. Our customers are using a spot instance massively. When they using T3 media and they got interruption rate, they got interrupted, and we would have this interruption time. And I can tell you, the spot interruption is slow, changed, which means that it can be predicted. It can be
Hmm.
predicted. It is predictable. So what we are doing is we are using data and then machine learning forecasting to to give you this interruption line time for you. Okay, does that make
Yeah.
sense?
Yeah. Uh, does this also apply to GPU, GPUs, etc.? Because I think a lot of people would now have questions regarding that when if they are working on building or training their own LLMs, they would be using GPUs, and how would that work out?
Yeah, yeah, I can give you a real example of the hottest, not the hottest, but one of the hottest GPU is NVIDIA H100.
Yeah.
And when we check, I think US has low capacity, but if you're using it in Tokyo, and its on-demand instance is over $6,000 per month, but its spot instance of just 2,000, and it has an extremely low interruption rate. So you can use spot instance to lower your GPU cost,
Yeah.
but you don't have to worry about interruption.
That is amazing. Like that is one third of the cost in terms of GPUs. So if you are currently trying to train your models or you're using ML workloads, definitely go and check out CloudPilot.
Yes. For AI scenario, I want to mention that inference is the best use cases for spot instance because instant inference are short and stateless jobs, right?
Yeah.
And we have so many customers who are using spot instance for inference by the help of CloudPilot AI.
Hmm.
Okay, let me go back to the slides. Okay, cool. We can say if you're using Carpenter, they don't have spot interruption predict. They don't have spot fallback when the interruption happens. When I say fallback, I mean we would provision a new spot instance with lower interruption rate, or from our provision on-demand instance, then we do the migration, workload migration process for you automatically. You don't have this. One of our customers who are using Carpenter, and they receive spot interruption events every day. You can say at the peak, they receive over 40 times in a day. That's, I think that's twice an hour in a day. That is totally unacceptable. But when
Yeah.
they integrate into CloudPilot AI spot instance, you can see their spot instance reduced like 90%. That's amazing.
Hmm.
Mhm. Okay, the third drawback of Carpenter is Carpenter tends to provision the same instance in a node pool. That was really high risk. But Cloudpilot AI, while improving resilience with instance type diversity, like this one, we would provision like T3 nano or M5 large and R5 large, so we can create node across multiple instance types to help you lower the interruption risk. Yeah, this is node creation. Um, okay, yes, this is also a fantastic feature. We are enforcing the anti-affinity for replica distributions. Like, if you have three replicas, Carpenter will put these three replicas in the same node, in one node. But we don't do that. We will distribute it. We put one in the node A, the rest two in the node B, which can prevent the single node failing from impacting all replicas. This is very useful. Yeah, the last comparison is balancing the workload placement across nodes. If you're using Carpenter, for a time, you would find that Carpenter, tends to create a very big node. I don't know why. Very big node, like 64 cores, like
Yeah.
64 cores. We think that has a lot of risky issues. But in CloudPilot AI, we tend to provision like two smaller nodes, like 32 cores, and put your pod workload into this two different workload. Because if one of workload get reclaimed, you got still got another. This
Hmm.
is one of the different. And okay, any difference? Any questions about the comparison with Carpenter?
I think you
It's
mentioned 32 cores and 64 cores. Generally, people tend to go for much smaller machines. generally speaking. So would you be able to elaborate on smaller machine sizes, like more like what about 8 cores and 16 cores, which is generally what majority workloads use, and it's only a few use cases where you tend to use massive CPUs and massive amount of memory.
Agree. That is the best practice. Okay. So any comments or questions? No.
No,
Okay.
not right now.
Mm-hmm. Um, I can give you two case study about how CloudPilot AI help customers lower their AWS cost, but with resilience. The first is from an e-commerce customers called Trans.ai. They have a Spark on EKS clusters, but before they met us, the e-commerce industry has a very sudden traffic. They have up and downs, but before they met us, they buy the resources with a fixed spend by the peak demand, like 300 EC2 instance. But in the middle net, really, small little persons using their website, so there's a huge waste, like 80% of resources are wasted. But after they integrate CloudPilot AI in their system, they got this beautiful green line that
Yeah,
they fully elastic, only pay for their actual use. I think Class Autoscaler cannot do this, and Carpenter cannot do this with the same cost because we provision like 90% of their instance are spot instance, and they don't got any interruption issues. Okay, so the result is we help them reduce 60% of EC2 cost saving. Also, they scaling very fast. You can see the green line. They scale very fast. They scale to like uh, over 200 EC2 instance in just a few, I think a few minutes. Yeah.
yeah,
This is a use case. Also, another use case is for GPU cost. Yeah, I mean, as you mentioned just now, um,
yeah,
these customers they find GPU is really expensive, so they are multi-cloud. They have AWS and also have Google Cloud. They are using like T4 GPUs, but the price of T4 GPU is lower in Google Cloud, so they have
yeah,
a network line between these two clouds. But the network line has a network fees. It was not economic. They find us and we tell you that how do you know that T4 is the best GPU candidate for you? Actually, they are not because they are using on-demand instance. They don't know about spot instance. We find, you know, G. I think it's G5G. Yes, G5G, which is powered by Graviton or ARM based, yes, this
yeah.
is really cheaper, like 20% cheaper than T4. So we
Hmm.
found this price and we help them to do the scheduling, help them to manage a spot instance for them. And they managed to have 52% reduction in the GPU cost. Yep. And
Yeah,
also they have the multi-architecture GPU support.
yeah.
Um, the last case study is about the workload autoscaler. So what we are talking about is all about the node autoscaler, right? The node
Hmm.
autoscaler. But how about the workload autoscaler? You know, when SREs or application team want to deploy application into Kubernetes, they would set a configuration called CPU request or memory request. But how do you know that the exact number of CPU requests? Like that, for example, if you request a 4 cores and 8 gigabits, but what you only use like actually you only use like 1 cores, so that's a huge waste, and it happens in I think over 90% customers. Uh, because in 2024 over 2.6 million customers in AWS, the average CPU utilization is only 30%. It's only
Yeah,
30%. So you can see the different line. The orange line is they provisioned cores from AWS, which is mean that this is a month you're buying from AWS. The blue line is the CPU request line. You request how much, but the green one is the actual use one. We have this metrics from promises, and you can see these customers deployed CloudPilot AI. These three lines get closer. But I think in the memory use case, it has more clear. So our goal is to make the three line get closer so that you have the minimal waste. Okay,
Yeah.
I think we
S-
can have a
One
demo.
one
Yep.
question in that particular one, which you showed. So you mentioned about how everything will come closer, which is very handy to fine tune your workloads. Even in terms of scaling, do you all have your own HPA?
We are developing our own HBA currently, but and this in this use case we don't have HBA integrated. So I think your
Got it.
question is how to manage the conflicts between HBA and VPA, right?
Uh, m- not completely. So I do understand that you all would take care of it, but my question was more specifically due to when you are scaling your respective pods or your workloads, you tend to scale it using your HPA. So what happens is your HPA scales your workloads, and in the background, the cluster autoscaler kicks in to scale your nodes based on the size of how many pods do you have running. So that was the part where I was curious to know whether y'all help with that scaling, since not only would you scale your workloads or pods based on CPU and memory, but you could also do it on the basis of um, LB transactions. So the number of connections to the load balancer. So for example, in GKE, we use number of connections to load balancer to scale um, our HPA, or to basically ensure that a workload scale out. When y'all are looking into building your own HPA, are those things that y'all are also considering?
Yes. To be honest, the HPA product is under developing right now, so it's not the right time for me to disclose more details.
Fair
But
enough.
yeah, but I can tell you what you are talking about, multiple sources to trigger the scaling events is one of the future. And there are some amazing, awesome open source project like Kita who can
Yeah,
solve this problem too. Yes, that was a very good solution. Yep.
yeah, awesome.
And how about we have a live demo?
Yeah,
Okay.
let's go for it. And hopefully the demo gods are on our side.
Okay. Okay, you can, this is our website, CloudPilot AI. You can just click get start and you will get into our demo um, dashboard, and you can, register it by your corporate email or GitHub or Google, and you have this dashboard. And the onboarding of our platform is pretty simple, like 2 minutes, 2 clicks, 2 minutes and 2 clicks. At first, you can click add clusters. So there's a EKS clusters supported right now, but we will support a GKE very soon, and Azure by the end of this year. But let me take example of EKS. We will give you a script. If you copy and paste into your clusters, EKS clusters, we will install our agent into your clusters. And yeah, so let me, like for 1 minute later, you can see your clusters appear on our dashboard. And let me take example of a demo cluster, like yeah. So cool. And yeah, so you can see your demo clusters appear on our console, and we will detect it, identify it's a AWS EKS clusters, and its region is US East 2. And oh, some bug. Let me refresh. Oops. Yeah. Its monthly cost is over $9,000 and you have 6 nodes. And this is a resources allocation about your clusters. Let me explain it in the big ring. Like in the green one, it is actually the provision amount you're buying from AWS. You are buying 11 cores from AWS. And the
Yeah.
blue one is number of requested. You requested like 5.9 cores. So its allocation rate is 45% or
Hmm.
54%. It seems good, but actually you requested 5.9, but this is what you actually use. You only use less than one course. So the CPU utilization is just a 4%. That's the problem. So how do we solve this problem? I can give you an example. If you click into your clusters, you will have the spend monthly current monthly spend and your trends here, and also you can have your node list here. You can have the all nodes, and also you can have your workload here, and you can have a lot of things here. But the most importantly, so our agent detected that you have 94% savings. Uh, so we can save this much of money. When you click save now, okay, this is a optimization plan we generated. I can explain it one by one. Let's from bottom to top. Uh, on the left pad is your current cluster configuration. On the right is the optimized recommendation configuration that generated by CloudPilot AI. You have four T3X large and its size is 4 cores 60 gigabits. Its pricing option is on-demand instance, and each node costs you $121 per month. At this moment, we find the workload you're running on these 4 nodes is very small, and you have like 10% CPU addition. So the first strategy is we want to downsize. So we recommend you to downsize from 4 cores, 60 gigabits, to just 2 cores and 2 gigabits. Okay, the second strategy is that we search on our data spot instance database. Let me show this tab. Yes, it's T3 small. Yeah, you can see it's pretty safe. It's pretty safe in the US East one. So we want to convert this node to the spot instant, and it only costs you $5 per code per node. Yes. Yes. So this is the first strategy. The second strategy. When I say second, I mean the first one. Um, okay, let me share this tab. When I say let's check about the first one. The first one is also optimized from on-demand to spot, but as I said, it can be applied to GPU. P3 instance is powered by NVIDIA V100, and its on-demand instance is over $8,000, but its price in spot instance just for $300. You can use it and you know put give everything about interruption to CloudPilot AI. We will do spot prediction. We will do spot automatically fallback for you, so you can enjoy the lower price of spot instance, but you don't need to worry about the interruption. Okay, the last strategy is the most tricky one. Um, the same size, 4 core 60 base and a 4 core 60 base, because our agent find that these CPU utilization of this node is pretty high. You cannot downsize. Also, we don't recommend you to convert from on-demand to instance, because let's search on our database. Yes, M5, and you can see in the US East 2 it is in red, which means it's not safe to use. So we just changed the instance type to M5A. Okay, so you got like 50% cheaper. That is because M5A is powered by AMD. As I said before, any instance at the same size, AMD powered is generally 50 cheaper than Intel one. They do have some performance difference, but I promise you, just like 5%, within 5%, over 90% of workload who can run on M5X large also can run safely on M5A. You don't have performance issues. So this is the phase one. Install our agent, get the saving report, and um, we only have read-only permissions. You can check these permissions on our documentations. Um, when you think this is very good, I wanted to do the optimization, fully autonomous optimization. You can click Start Optimization. We will give you another script. You can copy and paste, which we can request the permission to scheduling the nodes on behalf of you. So also we supported like progressive migration, which means that you don't want to, migrate these like 6 nodes in a batch. You want to migrate from one node to another node one by one. Yeah, this is a we also support it, but Carpenter do not support it. So if you click start optimization, and we will do the rebalance job for you. It has 3 steps. The first step is just a launch replacement. The second
Hmm.
step is we would do the dream node things. We will migrate from one node to the new node. Then we will delete the old nodes. Okay. There are some very good feature I want to mention. The first one is you click workload. If you have multiple replica workload, you can put 2 of them on mean non-spot replica, which means that you can put 2 of them on demand instance. The rest 80 of them were, put on the spot instance. Even if the 80 spot instance got interrupted at the same time, you still have 2 replica, serving. We call this fine-grained spot and on-demand scheduling strategy, which is only supported in CloudPilot AI. You cannot find it in Cloud Autoscaler. You cannot find it in Carbonite. Okay, that is also you have the node class. You can have like instance type, instance name, and your disk. Also, you have node pools. Yeah, so you can have your instance families, like you only want to provision from M5 or C5 like this. Okay, you want if you workload supported ARM, you can also have multi-architecture. Also, if you don't want to use Spot, you can just cancel it. And also, if you wanted to provision a specific rules, you can check it. Also, if you want to, you know, um, provision a node less than 32 cores, and we only choose from this instance less than 32 cores. So you can have multiple configurations, a very rich configurations compared to the Carbon. Yeah, and not the last feature I want to introduce in is about the workload autoscaler. So if you click the workload autoscaler, you can say from a namespace, you can see all workloads in the namespace. For example, this CloudPilot agent, your CPU request is like 0.25, but
Hmm.
actually, in the week, you're only using like 8.8 cores, and we recommend you. We give you this recommendation value that you can you can downsize, you can fine tune your CPU request from here to this number, and you got like 3 cores saved, 60 gigabytes saved. Yes,
Yeah.
and the most important feature is that when you using like in place, if you're using like 1.33 Kubernetes, there is a very cool feature called in place. In place means that you don't need to restart your pod. when you fine tune change your CPU request value, that was really, really good for some Java workload. As you know, Java workload, start up very slow, and they need a lot of, spikes of CPU. So at the startup time, but when they, running smoothly, their CPU usage will be very, very low, like 20% of the start CPU request. So in place is really helpful for Java workload. Okay, that's a left demo of our product. See
No, that
any?
that was fantastic. I think it's definitely people should go and try it out themselves to wait and see, try it on your dev cluster uh, to figure out, is this actually deriving value? Are you actually deriving value out of CloudPilot? And go and check it out. I think the only other part which I would probably mention other than this would be, I think one of the questions where people would always ask is, what about Cast AI?
What about what?
At Cast AI. So Cast AI would be one of your competitors
Yeah,
where they're performing something similar to y'all. And I think very recently there's another company which has just started within Australia and it's called Glasswing. So I think people will always compare your product with that. So do you have any thoughts or words regarding that?
hmm I'm sorry, I don't know the second company you mentioned, Australian, but
Mhm.
we know Cast AI. Cast AI as a very is also a great company. They offer great solution. I cannot talk too much about our customers in public, but I can tell you that the main difference is that we have a local agent in your clusters. But from as far as I know, Cast AI do the scheduling strategy decisions fully in their backend. So what if their background get interrupted or get done, have a downtime? So I think
Yeah,
scheduling will be a mess in your
risky.
class.
Yeah, yeah.
We still have a
That's
local agent, and we were, back to the class, just back to the Carbon or CloudPilot AI or a cluster autoscaler. That is the
yeah.
main difference.
That is very insightful, and I think that is something which everyone would want to know. What happens if Cloud Pilot goes down? It's fantastic that no one needs to worry about it. I think this was a very informative session, Jinkang, and something which a lot of people in currently would be looking at is how to optimize your resources and reduce your cost. So this has been a fantastic session. Thank you once again for coming on to Odyssey Cloud's every weekly seminars, and we appreciate your time.
Thank you,
Thank you.
Emmys, for having
Hope
me.
all
I
of
give
you
it.
all hope all of you all love the session. And as you can see, look at cloudpilot.ai, go and check it out. You all will be in for some really good surprises. And as Jinkang mentioned earlier, they are coming out with new features every single month. So if it is not on a cloud provider you currently are already using, they are going to be releasing GCP next month, Azure by the end of the year. Definitely keep an eye out on this and go and check them out. Thanks,
Thank you.
everyone.
Bye bye.